So in the previous question, we found that once the particle P has reached B, it turns around and has a new velocity vector of 2, negative 3.5. So now it wants us to find the total time taken for P to move from A to a position which is south of A. Okay, so we know that A has the position vector 7i minus 10j. We know that the particle's moving in this direction. And so when the particle is somewhere south of A, it's going to have the position vector of 7 something. We just don't know what the j vector is. So let's set up an equation. We know that the position vector of B from the previous question is negative 8, 14. So it's starting off at B, so let's write that down. Negative 8, 14 plus some time t times the velocity vector, 2 minus 3.5, is going to give us 7 and then some j vector that we don't know. But we don't need it, because just the top row gives us an equation with which we can solve for t. So negative 8 plus 2t is equal to 7. So 2t is going to equal 7 plus 8, which is 15. And t is going to equal 7.5. But we're not quite finished, because it wants us to tell them the time from A, not the time from B. We already know that it takes 3 seconds to travel from A to B. So the total time from A back to is just 7.5 plus 3 seconds, which gives us 10.5 seconds. And that's the answer.